So we've already seen the integer type. And that's an integer literal. The 59 is. I can also use a hexadecimal literal. I can also use an octoliteral by prefixing the number with just an O. I can have unsigned integers. I can have long ints. I can have character literals. But keep in mind that characters are actually an integral type, meaning they're stored in memory as integers. I can set that equal to 66 if I'd like. And I won't go into arrays here, but just to show you how things print out, I'm going to do a string literal. And we can store strings in an array. And then finally, I can also have floating point literals. And I'm going to use floating point literals in my arithmetic here just to make sure that it performs floating point arithmetic. I can also have double precision floating point. Now to print these values, remember that we have to use control strings. So far we've seen %d for integers, but there's several other types. %x for hexamal, O for octal, U for unsigned, C for character, F for floating point, and S for string. So we'll print x, but x is an integer, so we can also print it as a hexadecimal. We can also print it as an octal. And let's see what our other integer types were. Looks like x, y, and z. So I'll print out x, y, and z. So c was a character. We use that with a %c, but it's also an integer. And so of course we can also print it as hex. We can also print it as octal, but we won't do that. And let's also print k that way. So to print a floating point, we're going to use %f. If we want to format it, we specify how we want it formatted. So for 2 decimal points, I'll put a .2 before the f. Notice how the entire control sequence is still highlighted. And s was our string. So we'll use %s there. So let's compile what we have so far. It looks like we have an error. We're missing a So let's line these up while we're editing this code. Okay, so they're both in column 15. We'll do the same up here. Or column 28, I guess it is. B and A we haven't used, but that's okay. Again, normally we don't want to ignore that, but we'll do that here just for simplicity's sake. So now let's run, and then we can see, well, let's bring up what we've set everything to. So X is 59, 3B hexadecimal, 73 octal. And you'll notice these are lowercase. I think we must have used a lowercase x for hex. So if we do a capital X, I believe that will take care of that problem. So let's compile and run again. Yeah, that's better. It's easier for me to read. So Y was 10. We initialized Y with A, which is hexadecimal 10, 12 in octal. And then Z we initialized as 13 octal, which is 8 plus 3, which is 11. That's B in hex and 13 in octal. C is A, which is 65 int and 41 hex. And K is B, which is 66 int or 42x. Notice it's one more than A. In fact, we can actually do arithmetic with character types in C because it's just an integral type. It's just that when we use it as a character, for example, in a string, then it gets treated as whatever the ASCII code is for that particular number. So in this case, since we're treating it like a character, it's going to print the ASCII code or the ASCII character at 65, which is A. So just as a few examples of integers versus characters, if we print 100 minus a hex value A versus if we treat it as a character, 100 minus this character literal A, we're going to see some differences. Remember the hex value A is 10, so that should be 90, and we'll see what the character value gives us. Notice it's 35. And if you remember, that's because the character A has the ASCII value 65. So when we did that arithmetic right here, that's equivalent to saying 100 minus 65. So we can print the alphabet. by printing a character. And in this for loop, each time through the for loop, we're going to add the loop variable to A. And so we're going to print ASCII value 65, then 66, and so on. And this will eventually print the entire alphabet. We'll print a new line at the end of our code. And you can see it prints the entire alphabet. It looks like we didn't print D, A, or B. Let's see. Those were the unsigned and longs. So let's see an example there. So A is an unsigned and B is a long. So since it's unsigned, we want to make sure we print it as an unsigned integer. And if we print it unsigned, let's see what happens. And actually, let's also print it in hex, because that's always interesting. And B is a long, so we're going to use LU to print it out. And our last one was D. So let's try that. So I think now we've printed everything out. We have an error 37. We're missing a semicolon. So we're still not using D because we didn't change this to print D. And we can see now we're printing everything. Now notice something's weird with A. So A is an unsigned int that we set equal to -40. So notice, since it's unsigned, there's no negatives. So I wind up with some other value. Now that value you can't represent that with a signed int because the values don't go up that high. They wrap around to the negative numbers. Notice if I print it out as an unsigned int, then it works. Or I'm sorry, if I print it out as a signed int. So I have a typo there. So even though this is an unsigned int, that has some value. And so when I do that assignment, C doesn't have any sort of problem with saying, okay, -40, I know what that looks like in bits, so that's what I'll set this unsigned int to. So you want to be careful there. You can definitely get yourself in trouble if you're not careful when you're working with unsigned and signed values. Okay, so the other thing you can notice here is that it doesn't matter whether A is signed or unsigned. I can print it either way, just like I can print it as a character or an integer. So you want to make sure that when you're printing things out, you're printing it with the correct control sequence, because if you don't, you may have output that doesn't really match what's going on. If I thought A was supposed to be -40, but I was treating it as an unsigned int, look what I'm getting. Okay, so you want to make sure that you're careful with how you set these up. Okay, so one last thing. If I want to print things out in nice columns, I can give it a number before the type, and it'll print in a column of 10 or whatever other number. So For the character, I don't need that many, so I can make that, let's say 5. And I'll print X, C, and F here. And so you'll notice it prints out those values in columns. So that's just another thing I can do with printf. It's a pretty powerful tool to where you can do a lot of pretty interesting formatting. You just want to be careful that you have the correct control sequence, especially when it comes to using different types. So it's possible in C to figure out how big or how many bytes each of your data types takes up. So let's do that. We'll start off with the character. And I'm going to put a tab in here. And the size is going to be a long integer. And we'll stop there for now. So the function sizeof char returns the size of that data type. You can also use this with a variable. And when I print this out, we see that char is 1 byte. Now, what does that mean? So you may ask yourself, if it's 1 byte, what sort of values can I put in there? Well, there's a header file called limits.h, and that has some special values that tell you what the max and min or each data type are. So let's add another tab, and we'll say the min is that value. Another tab, the max is some integer value. And I don't want to print those as characters because the characters are probably going to be outside the ASCII range. And so I'm going to wind up with some potential weird output. So I'm going to print them as integers. And I need to expand my window here. Char min, char max are defined in limits, and those give me the min and max value for the character. And I misspelled it. So you can see that for char, the size is 1, and it ranges in value from -128 to 127. And I'm losing 1 from the positive side so that it can represent 0. So I'm not going to go through all of the data types and so forth there. I'm just going to copy all of this information for all the other data types into this file. And you can take a look at it on your own. Looks like I want to try to line up the colons there. And so you can see that we have char, int, short, long, unsigned, long, float, double. We could do the same thing for signed, unsigned, and so forth. And let me make sure I save this before I compiled. Yeah, so there you go. There's your values. And you can see that for long and unsigned long, all of a sudden we get some pretty huge values. I didn't print the min for unsigned long because the min unsigned would be 0. But anyway, this should give you an idea of what sort of values you can expect to have access to in C. And these are all very machine dependent. If you're working on a 64-bit machine versus a 32-bit machine, these sizes are going to be different. Some compilers might even have larger sizes that they let you do. It just depends on your compiler and your computer what these specific values are. So the C standard does expect certain minimums, but usually a lot of these will be larger than what that minimum value is.